In this video from LearnElectrics, we will look at using the three-way test lead that comes with most multifunction testers. New starters in the trade and apprentices have often asked the question, my multifunction tester has a three-way test lead with a 13 amp plug. What can I test with it? There is so much that we can test with this lead, and this slide gives you an idea of some of the tests that I can do with my meter using the three-way lead. Every meter is different. Check what you can do with yours. The first thing to understand when testing sockets is the correct pinout of the socket. This is shown here, and it is important that you understand the correct positions. Sockets can be unswitched, switched with single pole line only, or double pole that switches both line and neutral at the same time. If we look at the front of the socket, we should note that the line is on the right hand side, and if we look at the pins of the plug, the line is on the left hand side. Take a look at your own three-way test lead now and note the pin positions of the plug, and you will have three colour-coded connectors or round pins at the other end that go into the test meter. Some test leads, as shown here, have colour-coded plugs, and the test meter will have corresponding terminals for each of the connectors. It is very important that the connectors are plugged into the correct terminals of the test meter. Let's start with testing voltage and frequency. Set your meter to the voltage range, and just a little note here that some meters will use the letter V for voltage and others will use the international letter U. They mean the same. With the three-way lead connected to your test meter, insert the 3-pin plug into a socket outlet, making sure it is switched on if appropriate. If a voltage is found, the voltage and frequency will be displayed as shown. Ensure that the test lead plugs are in the correct sockets, as most tests are polarity sensitive. But testing voltage is the exception to the rule. Red and black can be reversed for AC voltage checks and will still give the same result. What should the voltage and frequency be in the UK? The Western European supply voltages were all harmonised in 1995. Shown here are the old voltages for the UK and for Europe, and you can see they are different. But today's voltages are harmonised. They are all the same across Europe as shown in the chart. We call these the nominal voltages. It is the name that we give them regardless of what we actually measure. When we measure a 230 volt supply, the meter will most often read about 240 volts actual voltage. This is normal, as the power stations are still outputting voltages using generators installed before 1995. And not until new power stations come online will we start to see voltages centred around 230 volts in the UK. When doing calculations, we use the 230 volt nominal voltage. Let's look now at ZS or PFC tests. This is one of the most useful tests with a multifunction tester. It tells us so much about the circuit, if you know what to look for. The chart here shows the different tests that this meter setting will give us, and shown here is PFC or prospective fault current as measured at the socket. This is not the PFC measurement that we record for the origin of the installation. That is measured back at the consumer unit. There are various names for PFC as shown. What we want from this test is the ZS value, the loop impedance of the system for that circuit, so that we can compare this to the tables in the on-site guide and the wiring regulations. If we carry out a ZS or PFC test, what does this tell us? It actually gives us a lot of useful information. It tells us the prospective fault current for this circuit at this socket. It also tells us the ZS for this circuit as measured at this socket. It tells us the voltage is within an acceptable range. If it wasn't, the meter would not do the test. And we know that the polarity is correct because the test has been completed. The test has also found an earth connection, and a line and neutral connection has also been found. If we were to do this test with the leads in the wrong position, the meter would not start the ZS test. The meter will display a warning symbol and a no voltage symbol to indicate that it has not found a voltage on the red pin of the meter and has aborted the test. If there is no earth found on the ZS test, then again the meter will not start the test. The warning symbol will be shown along with a cable fault symbol. If, however, the meter will not start the test and you suspect that there is a line and neutral reverse polarity at the socket, the easiest thing to do is to change the red and black leads over on the back of the meter and do the test again. If the test is completed and gives a result, this is confirmation that the socket has reversed polarity. In this case, 2 wrongs make a right. Reverse polarity at the socket and reverse leads make it right. All that needs to be done now is to correct the socket wiring. We can also test for the correct and reverse polarity as a direct test. Look at this chart. We can compare the difference between correct polarity and reverse polarity. But how can we test this? We can do this by rearranging the order of the connectors in the meter as shown here. Remember that the voltage is always measured between the red and black, so this is easily done and quickly proves polarity. We can also test for dead. This test will only show if the socket under test is dead. This test is not intended to replace the proper safe isolation and lock-off procedure. Again, we are going to use just the red and black meter terminals. To test for dead, rearrange the connectors into the back of the test meter as we did for the polarity checks. The 3-way test lead is also used to test RCDs at the sockets. When testing RCDs, ensure that the test connectors are in the correct locations. Check the type of RCD that is being tested. Is it a type AC or a type A, etc., and set your meter to the correct type and rating. The current wiring regulations require that all domestic 13A socket outlets should be protected by a 30mA RCD of the correct type. Regulation 643.8 tells us that general non-delayed type RCDs should be tested at the rated residual operating current and should trip in 300 milliseconds or less. The 3-way test lead is much more versatile than at first appears. There are many variations and capabilities of the test. It all comes down to you knowing your meter. Remember that these tests are live tests, so take appropriate precautions to protect yourself and others. Always carry out the correct safe isolation and lock-off procedure before dismantling a circuit. In the end, it comes down to knowing your meter and knowing how to test before you get to the customer's house. Thank you for watching. It really is appreciated, and we hope that you found this video useful. Please subscribe to our channel to get access to all of our videos, and remember to click on notify to be sure of not missing our next video. And you will find even more information, videos and help on our website at LearnElectrics.com. And don't forget that you can also type in LearnElectrics, all one word, into the YouTube search bar to go directly to our channel at any time from any computer. We are constantly adding new videos to our channel, so don't miss the next one. And once again, thank you for watching, and we hope to see you again very soon.